Hai, Assalamualaikum dan salam sejahtera. Nama saya Nurada binti Irfan. Nombor matrik D20182085919. Saya dari kumpulan B. Nama pensyarah Dr. Wan Muhammad Nuzul Hakimi bin Wan Saleh.
Hai, nama saya Wan Nur Afifah binti Wan Muhammad Syafri, bernombor matriks D20182085937. Video kami pada kali ini akan menceritakan sedikit tentang family of organic compounds.
These are examples of the leading types of organic compounds. Each type has a characteristic grouping of atoms which identify it, and all can be considered as derived from the hydrocarbon methane. For example, substitution of the hydraulic group for a hydrogen atom in a methane yields an alcohol. These and other characteristic groups are shown in colored box. Substitution of a double bond oxygen atom for two hydrogen atoms of an alcohol gives an aldehyde. The name aldehyde also suggests alcohol less hydrogen, as comparison of the formulas will show. Addition of another oxygen atom to an aldehyde yields an organic acid with the characteristic group COOH, and ester can be considered as a sort of an acid. In acid format, for example, an ethyl group has been constituted for the hydrogen atom of the characteristic group of formic acid. Aldehyde and ketones. The aldehyde and ketones contain what is known as the carbonyl group. A carbonyl group is a carbon atom double bond to an oxygen atom, CO, and the carbon is also bounded to two other atoms or groups. In an aldehyde, the carbonyl group is always on a N carbon. In a keton, the carbonyl group is never on a N carbon. Esters. Have you ever wondered why an orange has such a wonderful aroma, or where the smell from a freshly cut pineapples come from? Most fruits get their rich aroma from molecules known as ester. Ethyl ethanite is responsible for the smell for orange, which butyl buttonite is best known for the smell of pineapple. Ethyl ethanite, orange flavor, which is butyl buttonite is pineapple flavor.
Next is ethers. All ether compounds have the general formula ROR0, where R and R0 are both alkyl groups, which could either be the same or different. The most common ether is a compound also known as diethyl ether. The structure of diethyl ether is shown below. In this structure, the alkyl groups on either side of the oxygen atom are ethyl groups, hence the name diethyl ether. N-amine. N-amine is a derivative of ammonia in which one, two, or all three hydrogen atoms are replaced by hydrocarbon groups. Amines are classified as primary, secondary, or tertiary by the number of hydrocarbon groups attached to the nitrogen atom. Amines are named by naming the alkyl groups attached to the nitrogen atom, followed by the suffix amine. Amines are bases. They react with acids to form salts. Salts of aniline are properly named as. And lastly is N-amides. Amides have a general structure in which a nitrogen atom is bonded to a carbonyl carbon atom. In names for amides, the ic acid of the common name or the oic ending of the IUPAC for the corresponding carboxylic acid is replaced by amide. Amide are natural compounds in contrast to their seemingly close relatives, the amine, which are basics. The amide linkage is planar, even though we normally show the C-N connected by a single bond, which should provide free rotation. Amide can be synthesized from amides, carboxylic acids, alkyl halide, and acid anhydrides. Amides can be hydrolyzed under acidic or basic conditions and can also be reduced to amines. That's all from me. Thank you.